Doppler 24 so advanced? Well, I'll be joined by other members of the Action News 24 meteorology team. Meteorologists Tom DeVecchio and Dave Call to explain to you how all elements of the radar work to give us the best information available so we in turn can give you a better forecast. Plus, we'll be joined by the Hamot Health Foundation folks, our Hamot Doppler 24 partners, and show you how Doppler is helping to save lives. But the first question you might be asking is, why is Hamot Doppler 24 here? Well, an advanced local radar was really needed when the National Weather Service in Erie shut its doors in 1996. This ended an over 120-year reign of government weather presence in the town of Erie. Many government officials were quick to point out the problems of not having a weather office or a radar here in Erie.
Clearly, our community has the worst weather radar coverage in the whole Great Lakes region. The GAO uncovered that.
It is an intolerable situation with Erie not having its own forecasting. We have had failures in the snow prediction, failures in the tornado which touched down. This is a key locale. This is a spot which is hit by tremendous snowstorms. The tornadoes are not all that infrequent, but mostly the snowstorms. I land here often enough to know that it's 14 inches every time you turn around. And it really paralyzes the area, and Erie's entitled to have first-class equipment to tell Erie what's happening weather-wise so the people are not taken by surprise.
With the Erie office closed, the forecasting duties for our area were shifted over to the National Weather Service office in Cleveland. And we quickly discovered that during times of severe weather, Cleveland did not provide the best warning.
I think they've over-forecasted, under-forecasted, under-warned, and over-warned since they've departed. Well, when our station was here, we had a very experienced staff. All the people were ex-military weather people, and you're on duty 24 hours a day watching the radar, working on weather maps, analyzing weather maps, and you could see the situation. I don't believe they have enough experienced personnel, and Erie is in an area where you get a lot of these storms that just generate right here.
For example, in 1997, Cleveland completely missed a tornado that struck Union City. Luckily, no one was injured, but residents did suffer some damage and rattled nerves.
It turned black, the trees started blowing in the winds, and I looked out my kitchen window and I seen Tom Tarbell's trailer blow over just like a piece of paper.
We just had like 5 seconds, just enough time. I heard my trailer rumble and I heard crackling, and I grabbed my daughter and jumped in the bathtub.
My husband told us to just go down the basement, and I looked in the kitchen window and seen debris flying across the backyard.
So why can't the National Weather Service radars give Erie the coverage it deserves during times of severe weather? Meteorologist Tom DeVecchio joins us now with the answer.
Thank you, Tom. Here in the Erie region, we are covered by 3 NEXRAD Doppler sites. One is in Cleveland, Ohio, one in Pittsburgh, and one in Buffalo, New York. Now, each one of these NEXRAD Doppler sites sends out radar beams from different levels to the ground. But even at its lowest level, these radar beams do not move over our area until they are about anywhere from 10,000 to 12,000 feet above the ground. And that can cause a problem when it comes to detecting precipitation and low-level wind shear. Here's an example. We'll turn now and look at our Hamot Doppler radar. This particular image is from Wednesday morning, August 11th. And notice that we do have some scattered showers out over the lake and a pretty good cell in the eastern part of the city of Erie. So the precipitation is light to occasionally moderate rainfall, especially with the yellows there near Erie. Now, what I'm going to do is pop up what the Cleveland NEXRAD Doppler radar is picking up at the same time. Notice there's nothing. The radar beam in Cleveland is totally overshooting all of that precipitation. As you switch over to the Pittsburgh NEXRAD site, again, not showing any precipitation because the radar beam is overshooting the site. As we move over to the Buffalo radar, it is picking up a little cell in the northeastern section of the city of Erie. That is it. So as we pop back the current Hamot Doppler radar image, a lot of detail with the Hamot Doppler that definitely brings home the point, the fact that the other NEXRAD sites overshoot us. That is very important, especially in the detection of lake effect snow, which I'm sure we'll be saving for another show, but also in the detection of low-level wind shear, which is one of the trademarks of a possible tornado. When the NEXRAD Doppler radars are overshooting this wind shear pattern, our local Hamot Doppler radar can pick it up, and we can better warn you of impending severe weather.
So the presence of a local radar was needed. That's why in 1998, WJET, TV24, and Hamot Health Foundation came together to build a Doppler radar that would provide the coverage our area needed. Hamot Doppler 24.
Hamot Doppler 24 is an important part of the mission of our television station, and that is to service our community. We can't think of any other service in the community that's more important in providing our viewers with accurate, timely weather warning, in particular when severe weather occurs in a marketplace. We all know that there are many thunderstorms that can roll off of Lake Erie during the summer months, and of course the lake effect snow that we all experience in winter affects our daily lives, and we just wanted to make sure that we were providing our viewers with a service that would allow them to be educated and warned about all kinds of severe weather.
We saw this at Hamot as a very direct and very real connect to our mission in terms of serving our community, serving the region, and protecting as best we can the health of everyone in that region. So it made a perfect fit for us to have and be a part of this project.
Hamot Doppler 24 is the first of its kind X-band Doppler radar in the country. And operating at 300,000 watts, it's the most powerful broadcast radar anywhere around. Why is this so important? Dave Call joins us now to explain how Hamot Doppler 24 works.
Tom, our radar works on the same basic principles as most other radars, but thanks to advances in technology, it works better. Inside our dome is an antenna and dish much like this one. The antenna sends out an invisible beam of electrons into the atmosphere.
The Doppler X-band radar is 300 kilowatt pulsed power, which allows us to penetrate the fronts or the storm fronts or the clouds as they're rolling through the area, which will allow you to see through them, see what's behind them.
A dish in the radar dome collects all the returns from rain and snow, then this computer processes them and places them on the screen for us and you to see. Doppler radar uses additional principles of physics to detect what direction the rain or snow is moving. Knowing what direction the winds are blowing is especially important in severe thunderstorm and tornado detection. With our radar, we can provide advance warning of tornadoes thanks to its Doppler capabilities. Tom?
Thanks a lot, Dave. As you can see, there's a lot that Hamot Doppler 24 can show you, but there is one thing that it will never show to the benefit of you, the viewer, and that is ground clutter. Ground clutter, of course, are objects like hills, trees, even the Lakeview landfill that shows up on conventional radars as precipitation, much to the confusion of you and, frankly, us, the meteorologists, too. Thanks to the power and state-of-the-art technology of Hamot Doppler 24, what you see on the radar image will only be the weather that affects you and your family. And with street-level mapping, you will be able to see exactly where the storms are. Here's Dave Call now with an in-depth look at one of the most exciting features of Hamot Doppler 24. And that, of course, is street-level mapping.
Thanks, Tom. A typical storm might only be as large as the borough of Northeast or any other borough on this map. However, any areas of severe weather or tornadic activity are probably only the size of a city block or two. That's the advantage of street-level mapping. Street-level mapping is especially helpful when we want to show you severe weather, such as gusty winds, large hail, or tornadoes. With it, we can zoom in and let you know if you need to take cover or if you appear to be out of harm's way. It's another exclusive feature of Hamot Doppler 24. Tom?